So when you're getting into the world of Docker, you're probably going to start scratching your head when you look at some of the different Docker network types. Networking was already confusing as it is, and Docker decided to be like, hold my beer. Well, don't worry, because in this video I'm going to break down the different Docker network types. I'm going to go ahead and list out each one of them. I'm going to give you an example of how they work, and I'm going to give you a use case on when you should use each one of them. Well, at least that's what I hope I do. If not, you might just leave here more confused than when you came here. But anyways, let's stop wasting your time, because like you guys, I got to do. So let's go ahead and get into this video. So to start off, we should probably at least know what the different Docker network types are. And Docker decided not to just create one, not two, or three, but 6 different Docker network types. And those different types include the bridge, the host, the overlay, the IPVLAN, the Macvlan, and my favorite one of all, and for all the security guys too, the none network. And we're gonna go ahead and start with the bridge network and check that one out. All right, so we're gonna go ahead and start with the bridge network, and I actually went ahead and created a diagram to help you visualize and understand how the networking for it works. So let's go ahead and check that out. All right, so we have our bridge network here. This is the example, and we actually do have a switch. So we're gonna have our Docker host, which is a server. It might be something like Linux, and on Linux, it's gonna install the Docker software. And within the Docker software, you're gonna have your containers here, right? So we've got container 1, we've got container 2, and we've got container 3. And these can all be on their own different networks, but in this example, we're gonna go ahead and pretend that they're all on the same bridge network. And a bridge network is essentially a virtualized little network that's created with Docker, and it allows the individual containers on the same bridge network to talk to each other. Now you guys can have multiple bridge networks on a Docker host, and each one will be isolated from the other. So let's say we had a bridge network for container 1 and 2. If they were on the same bridge network, they'd be able to talk. However, if container 3 was on its own bridge network, it would not be able to talk to container 1 and 2. And another thing to note is that bridge networks are isolated to the host that they live on. So you can't have a bridge network on Docker host 1 here that will also exist over here. If you created a bridge network with the same IP networks, they'd be different bridge networks on different hosts. That's just how that works. And the main way bridge networks allowed you to actually communicate with the external network, so the network outside of the Docker host that might be connected up here, is by using port mappings. And how that works is, let's say we have container 1 here, right? And he is a web server. This is where you have a website that you use to show people your feet pictures. I'd probably want to check that out, right? So let's say I have a PC over here and I want to get to that website. Well, I know if I want to get there that I have to go over to this Linux host over here that's running the Docker instance. And what I'm going to be reaching out to it on is port 80, because that's generally the port that's used for web servers, right? So the container is actually also going to be using port 80, right? However, since we're using a bridge network, we're going to use something called port mappings. And what this is going to do is take the actual port number of this Docker host, port 80, and we're going to map it to port 80 on the container, right? So if traffic comes into this Docker host here, on port 80, that traffic is then going to be routed from the host down to the container. And that will allow the traffic to actually get to the container so that you can see your web server, or you can see your actual website. And it doesn't have to be port 80 on the host. You can actually map it to something else. Let's say that container 3 was already using port 80, right? Well, you can actually map this to port 8080, and when I reach out on my PC, instead, I will reach out to port 80 to reach that web service, and then this port will then be forwarded down to container 1 so that I can see those feet pics. And the same thing works with C2. Let's say we want to use LDAP services. We need to authenticate. Let's say I'm logging into this PC, and this PC is using this container's LDAP service to log in and verify accounts. Well, let's say I go and log in. That PC is going to send the authentication request over to the host on port 636, and the host is then going to go ahead and actually forward that traffic from port 636, so 636, down to my LDAP on port 636. to that container. And so the traffic between the container itself and the actual external network are never direct. The host is the one managing it. So it's going to be the one, this Docker host here is going to be the one that's managing the traffic between the container and the external network. Oh, and one thing I also want to mention with the bridge networks is that all of the traffic that's going to this LDAP server or this web server here on host 1 is going to be reaching out via the IP address of the host that the Docker is running on. So if I want to reach out to those containers and the services that they use, I need to reach out via the IP address of the Docker host. So they share the same IP address, however, we're mapping the ports on the host to the containers within the Docker host. And a good use case for bridge networks is when you want your traffic to be segmented from the external network and you don't want your resources to directly reach out to the network. This is also the default network, and it's actually pretty easy to set up. So if you're getting into a home lab and you might just want to start off with something easy, I would probably recommend the bridge network. So let's go ahead and now move on to the host networks. All right, so the next network type we have is the host network type. And with this one, it's going to be pretty easy to understand. Let's say we have the same example. We have a Docker host over here with a web server and an LDAP server. Well, if I want to reach out to those servers via the containers, obviously, I'm going to go ahead and still reach out to the Docker host via its IP address, right? Let's say I'm trying to reach the web server on port 80. I'm going to reach out to port 80 on the Docker host. However, there's no port mapping. I'm not mapping port 80 on the host to port 80 on the container. The container is actually just going to take over port 80 completely. He's going to say, give me that shit, that's mine, you're not getting it back. So when I reach out on port 80, I'm reaching out directly to the container. Now nothing else can be mapped to this. Nothing else can use it other than this container here. Be the same thing if I'm reaching out to port 636, right? I'd be reaching out directly to that container over here, container 2. The containers actually share the same network stack as the host itself and are directly attached to the network essentially. However, they don't have their own IP addresses. They still share the same IP address of the host. And the great thing about this is this network type is great for different containers that might need to handle a lot of data traffic coming in at once. Instead of having to deal with the overhead of Docker mapping the ports to each other and not directly sharing that network stack, they're able to actually go ahead and bring in that network traffic just as if they were a host on the network. Alright, so we're going to go ahead and dive into overlay networks now. But before we do that, make sure you guys subscribe and drop a like down below and let me know which Docker network type confused you guys the most and which one you guys are using in your lab setup or even in production at your job. But alright, now on to overlay networks. Alright, so the next Docker network type we have is overlay. And overlay networks are essentially virtual networks that only exist on a Docker host. So let's say we've got a network down here for 10.69.69.0/24, and this network is actually going to go ahead and exist on multiple Docker hosts. So let's say we've got Docker host 1 and 2. They will both be able to put containers on this network. It's not going to be exclusive to one host like it is for bridge or host networks. And with this, let's say we're going to go ahead and put C1 and 2 on Docker host 1 and C4 all on this same network. Well, we're going to want them to be able to talk, right? Well, we're obviously not creating this network on the physical network up here. We don't want to wait on those dirty network engineers to create the network. So what we're going to do is create them on the Docker hosts, and in order for those containers to talk to each other, the hosts themselves are actually going to create a virtual tunnel between each other. And they'll actually go ahead and pass any traffic between those containers. So between container 1 and 2 over to 4 via the tunnel. And it's encrypted traffic. The actual external network doesn't know what it is. It just sees encrypted traffic going between the two, but doesn't know all the specifics of it. And this network type is generally used in setups where we're using Docker Swarm. So we're actually going to go ahead and cluster these hosts together, and they're actually going to work together simultaneously. So let's say we have a web server, right? We have C1 over here, and I'm reaching out to see feet pics. That's general traffic. We might only need one container, right? Man, pin's starting to go bad on me. But we might only need one container, right, to manage that. Well, let's say all my friends are also trying to reach this container at the same time. The traffic's going to overload at this point. It's going to be too much for the one container. Well, we can actually spin up another web server over here on the same network, and they will load balance that traffic so that everybody can actually go ahead and reach this web server without any sort of latency or anything like that. And it can also be used for redundancy as well, right? So let's say this one actually crashes, it shits the bed, this one over here can take over and continue to hand out those feed pics. And of course, just like the previous two Docker network types, if I want to actually reach out to these web servers via the external network, I'm going to use the IP address of the host that the container is running on. It could be the IP address of this host here or this host here. Docker Swarm is actually going to manage all that, and it's going to cluster them together and manage the traffic and port mappings for that. Main takeaway for overlay networks: if you want your containers to be able to communicate amongst different hosts, and you also want that redundancy and load balancing, and you're using Docker Swarm, you're probably going to want to be using overlay networks. All right, so the next Docker network type we have is Macvlan Docker networks. And with this, the actual containers themselves are going to create their own little virtual MAC addresses, their own virtual network interface cards. So let's say the Docker host here has its own network card, right? And that's actually what connects up to the switch and can talk on the network. Well, the containers themselves are going to create little virtual network interface cards, and they're going to have their own MAC addresses. So the switch is actually going to see the MAC addresses of the containers. And from there, they can also receive their own IP address from the physical network. So let's say we have a network up here on VLAN 1, and its subnet is 1.1.1.1. These containers that connect to that Macvlan network down here will actually receive an IP address from that network. Now, these containers actually do support 802.1q, if you're familiar with that with the network engineers in the community, which means they're going to support tagged VLANs. So I can actually tag the traffic up to the switch itself, and of course the switch is going to have to be tagging those VLANs as well and have the VLAN existing on the network. And the great thing about this is that it can be used for those different types of applications that might be legacy and need to appear as if they are on the physical network themselves. To be able to do that, they're going to appear as if they're their own device. However, they're an actual virtual device, obviously a container with its own little virtual NIC here and its own little IP address. And the difference between Macvlans as opposed to the previous examples, if I want to reach out to that web server for the feed pics, I'm actually going to reach out to the IP address of the container. I'm not going to actually reach out to the host at this point. The container has its own IP address on the network, and I'm going to be reaching out directly to that on port 80. No more mapping ports or sharing IP addresses of the Docker host. Alright, so IPVLANs actually were a pain in my ass to understand for a while, and it might be for you as well, but don't worry, I'm going to break it down very simply. So with IPVLANs, we're going to have another Docker host, of course, Docker host 1. It has the same services as before, right? Well, with IPVLAN, we have two different options. We've got IPVLAN layer 2 and layer 3. And we'll start with layer 2. So this is going to be similar to Macvlan, right? They're going to be directly attached to the network. We're going to be creating sub interfaces on the host, and they'll be associated with VLANs and subnets that are actually on the network up here. So if there's a VLAN 1, we can actually attach the container directly to it and it'll receive an IP from it. But the difference here is that this is going to share the same MAC address of the host. So this guy's virtual network interface card here, this little thing here, is going to be the same as this MAC address of the host. We're not going to have a whole bunch of different MAC addresses for all the mini containers that might be running on this host down here. We're going to minimize the layer 2 traffic that we have traversing the network up here. But it's also going to have its own IP address like before with the Macvlans. But the big difference here is that we're sharing the same MAC address. That's it. Pretty easy for layer 2. But now we're going to go ahead and move into layer 3 of IPVLAN here. So with layer 3, we've got the same sub interfaces like before, the little sub interfaces. It's going to share the same MAC address. However, the Docker host itself is basically going to pretend that it's a router. So we are going to assign IP addresses. They could be their own network. So let's say C2 here is on its own network. His IP address is going to be 10.1.1.1. If I want to authenticate on port 636 and be able to log into this PC over here, this one here, I need to reach out to this IP address here. And how I'm going to do that The router is going to have this, or the Docker host is going to have its own network, right? So it's going to say, hey, I know how to get to 10.1.1. If you want to get here, which is obviously C2, you need to come to me. So let's say the Docker host's IP address is 10.0.1.1. If you want to get to 10.1.1.1, you need to come to me. So my PC doesn't do any routing, doesn't know. It's going to send it up to the switch. The switch is going to know, hey, he's going to have this route in his routing table already. The specifics behind that are going to be up to your network engineers, or maybe you if you're doing it. But you're going to have a route that says, hey, if I want to get to this network here, which is where my LDAP server is, I need to send it to the Docker host here. So then the switch or router, whatever it is, will send the traffic to this IP address via this port, and then the Docker host itself will send that traffic down for you to use that service for the container. So that's the big difference with this one. The host is going to act as if it's an actual router. So this Docker host here is acting as if it's a router. We're minimizing the layer 2 traffic that we're putting on the network. And the main use case for IPVLANs is when you want your host to be able to communicate directly on the network, like Macvlans. However, you don't want a whole bunch of layer 2 traffic and a whole bunch of additional MAC addresses to be being put on the network. We share the same one MAC address, however, we're actually using routing instead, which is generally the tradition we're going in for a lot of different things nowadays. But that's IPVLAN layer 2 and 3. All right, so we got my favorite network type of all, the none network type. And this one's great because literally nothing can talk to it essentially. You're gonna have a container here, let's say this time C3. We haven't actually used C3 at all. So C3 will be on a none network. Doesn't matter if he has an IP address or not. He's gonna be existing on this Docker host, and he'll be able to perform whatever functions he wants. However, nothing is talking to him. These containers here, container 1 and 2, cannot talk to this, and nor can anything outside of the network. That's why I didn't even bother putting anything here, because nothing on the network is going to be able to talk to it. It'll exist on the host itself, but it's the dirty redheaded stepchild. Nobody wants to talk to it, nobody wants to deal with it. He can just go sit in the corner. This is great if you want to go ahead and use it to deploy an application that needs to run some sort of batch jobs or whatever service it is, but doesn't need to talk to anything. Great thing about this is all the security guys are going to like it because nothing's talking to it, which means there's going to be no vulnerabilities for it essentially. And it's easy to explain. That's why I like it. But anyways, that's the none network type. All right guys, so those are our 6 Docker network types. We've got our bridge, we've got our host, we've got our Macvlan, IPVLAN, overlay, and none. I know that was a lot, but I hope I broke it down pretty easily for anybody to understand. There's way more specifics that you can get into all this, but those are the primary functions on how those different Docker network types work. I hope you guys got something out of it. Drop a comment down below letting me know which one you guys went with, and if I was just a shitty teacher overall, I wouldn't be surprised, honestly. I appreciate you guys' support. Make sure you subscribe because I got that Raspberry Pi 5 coming out soon that I'll be giving away. But anyways, you guys have a good one. Peace.